dear students. In the last session, we have studied how digital communication system process the analog information from transmitter to the receiver through communication channel and how original message is delivered to the final destination. Now, in the today's session, we will study how discrete information is going to be processed by the system and transmitted to the receiver side and deliver the same message to the destination user. We know that in digital communication system, there are two types of information source, that is analog or continuous information source and digital information source or discrete information source. Let us consider discrete information source generates a character and it will be converted into equivalent ASCII code by input transducer, which is called as keyboard. The ASCII code which is produced by the input transducer is having discrete set of values which can be forwarded to the source encoder so that it can be converted into equivalent binary bit stream. In the next step, channel encoder receive the output of source encoder and add the extra parity bit in front of the sequence of data bit stream. Here you can see 3 bit of extra parity bit is added in front of the data bit stream so that the output of channel encoder is this. Now this newly generated data bit stream is represented in a suitable electrical signal format and transmitted to the receiver side through communication channel. But at the receiver side, the signal which is transmitted by the transmitter will get distorted due to the external noise which will be added to the communication channel. This can be overcome by using next unit, that is called as digital modulator. Here digital modulator uses digital modulation technique such as ASK, FSK and PSK and produce the modulated or transmitted signal. Now this modulated signal is being transmitted to the receiver end through the communication channel. At the receiver side, digital demodulator convert this modulated signal into original data bit stream, which is as same as the output of channel encoder. Now the function of channel decoder is to remove the extra parity bit from that data bit stream and produce the binary data sequence which is as same as the output of source encoder. Another important function of channel decoder is it performs error detection and correction technique so that error can be removed from the data bit stream which is produced by the digital demodulator and make that data bit stream as error free. Now the source decoder will convert the binary data bit stream into equivalent ASCII code by using suitable algorithm and forward that value to the last element of communication system, that is output transducer. Now the function of output transducer is to convert the ASCII code into equivalent character and deliver that message to the final destination user. This is how digital communication system process the discrete information from transmitter to the receiver end. I hope you all understood how digital communication system process analog and digital information from one end to the another end. Let's move on to the next topic, that is baseband and passband signal. These two signals are very important in digital communication system. Let's begin with first type of signal, that is baseband signal. In digital communication system, our original message is generated from the information source and represented in suitable signal format by the input transducer. That type of signal is called as message signal or baseband signal. Example for baseband signal are audio or voice signal and computer data output such as sequence of characters, symbols and numbers, etc. Here baseband represents the low frequency range in the signal frequency spectrum, so that baseband signal is also called as low frequency signal or modulating signal. One thing you have to remember, in digital communication system, binary data bit stream, which is the output of source encoder and channel encoder, is also called as baseband signal. What do you mean by passband signal? As you know that in digital communication system, if baseband signal which is generated from the input transducer is modulated by some digital modulation technique, from digital modulator is called as modulated signal. So that modulated signal which is produced by the digital modulator is called as passband signal. For example, broadcast TV radio, radar and satellite signal can be considered as passband signal. In the next slide, I will tell you how passband signal can be generated by the digital modulator. Here, passband signal can be generated by using high frequency carrier signal from the digital modulator, which represents the high frequency range in the signal frequency spectrum. Hence, passband signal is also called as high frequency signal and modulated signal. In the digital communication system, let us consider one of the input of digital modulator is the output of channel encoder. If this binary data sequence are represented in low frequency signal representation, then this type of signal is called as baseband signal. Here, digital modulator will produce the passband signal as an output by using another input is called as high frequency carrier signal. Digital modulator always uses sinusoidal wave as high frequency carrier signal. According to the definition of digital modulation technique, some parameters such as amplitude, frequency and phase of the carrier is modified or varied by discrete set of values of baseband signal to produce passband signal as an output. Now here you can observe that passband signal always consists of high frequency component and baseband signal always consists of low frequency component. Now the detailed explanation about digital modulation technique will be explained in unit number 3. Let us move on to the next topic, that is baseband and passband signal transmission. So far we have studied what is baseband and passband signal. Now in the next slide we will study how these signal can be transmitted in the communication system. Let us start with baseband signal transmission. If the baseband signal is transmitted directly to the receiver side without modulation, then it is known as baseband signal transmission. Hence, baseband signal transmission do not require digital modulator unit in the transmitter, but this low frequency baseband signal has to pass through low pass filter circuit and then transmitted to the receiver side. Because without filter, this low frequency baseband signal cannot be transmitted to the receiver side through the communication channel. Baseband signal transmission is only suitable for short distance communication because low frequency baseband signal cannot be able to transmit it for the longer distance. This is one of the disadvantage of baseband signal transmission. Now this can be overcome by applying another type of signal transmission that is called as passband signal transmission. Now look at the example for baseband signal transmission. Computer data transmission within the local area network through wired media can be considered as the example of baseband signal transmission. Let's move on to the next type of signal transmission, that is passband signal transmission. If the baseband signal is first modified by the digital modulation technique and then transmitted to the receiver end, then it is known as passband signal transmission. That means in this signal transmission, baseband signal is first converted into high frequency passband signal using modulation process, so that before transmission of passband signal, it has to pass through the high pass filter circuit. One of the advantage of passband signal transmission is that it is suitable for long distance communication. Example for passband signal transmission is broadcasting TV signal, radio signal, radar signal and satellite signal over wireless link. That is all about baseband and passband signal transmission. In the next session, we will study merits and demerits of baseband and passband signal transmission and comparison between these two types of signal transmission. See you in the next video. Thank you.